Okay, chapter 17, part 2. In part 1, we just mentioned that the strong acid examples are HClO, HNO3, and H2SO4. Other than these three examples, you can take them as weak acid. There are many weak acids. Including H2SO3, H2CO3, phosphoric acid, H3PO4, and phenolic acids. And now we will look at the difference between the strong and weak acid. For to compare the two acids, we have a fair test. So we have the HClO and phenolic acid, but they have the same concentration, 0.1 m, and then they have same temperature. The volume of the two acids is not a main factor. It is not so important. And then we look at the result of the two acid pH. For HClO, the pH reached to 1. And then for the phenolic acid, it has a 2.87, not so acidic. The reason behind that, for the same concentration of two acids, for the phenolic acid, only partly ionized, so it has lower concentration of hydrogen ion, and the pH is not as low as the HClO. Next experiment. We have a HClO and phenolic acid are same concentration, same temperature, and you can have different volumes. Volume is not a factor. And then you dip 2 electrodes into the two acids and collect to a light bulb. As shown in the diagram, the result is bright light from HClO and dimmer light from CH3COH phenolic acid. Then it is the result. The reason behind we need to use the number of ions. For the HClO, it has for 0.1 m HClO, it has 0.1 m H plus and 0.1 m ClO minus ion. 1 m HClO, it has a 1 m H plus and 1 m ClO minus. So altogether, there are 2 m ions. And for the phenolic acid, it cannot have a 2 m ions because it is only ionized incompletely. So the conduction is not very well and the light dimmer. It is the two second experiments. Now we look at the third one. The third one is we put a magnesium into two acids, HA, and the other one is HB. And then we measure the volume at different time. At the beginning, the two acids do not start the reaction, so no gas evolved. However, when the magnesium reacts with one of the acid, it gives more hydrogen rapidly. The curve 2 is another acid. It gives the hydrogen gas lower rate, slower. But they have the same in total volume of hydrogen gas produced at the end of the reaction. So which one is faster? Which one is slower? Again, the strong acid has higher concentration of hydrogen ion. So it is the curve 1. The weak acid has lower concentration of H+. So it reacts slowly with the magnesium. But they have the same concentration. So at the end, they give same volume of hydrogen gas, although they have different rates of reaction. Okay, after the strong and weak acid, we now look at the strong and weak alkali. Strong alkali completely, weak alkali incompletely. Example here is NH3 react with the H2O. They are both molecules and then produce ions, so it is ionization. Ionize incompletely or ionize very slightly. And then for the alkali, sodium hydroxide or potassium hydroxide are strong alkali. It dissolve in water, give ions completely. However, we cannot use the word ionization. We need to use the word dissociate, because before the dissolve in water, they are ions. After dissolve in water, they are mobile ions. There is no change in bonding. It is not molecule change to ions. Ions produce ion. So we call it dissociation. Okay. Now we need to have compare. One word is called strength. It can be strong, it can be weak. For the strong acid or alkali, it completely ionize or dissociate. For the weak acid or weak alkali, it is incompletely ionized. The word concentration not depend on the arrow, and it depends on number of mole per dm cube. More number of mole per 1 dm cube, then it has a higher concentration. If the number of mole per dm cube is very low, then it has a lower concentration. High concentration, you can call them concentrated solution. Oppositely, it is a dilute solution. When the value of the concentration is higher than 1 m, you can call it concentrated. And less than 1 m, example 0.1 m, example 0.01 m, they are dilute solution. Oh, now, from our book, 12 m is concentrated, equal to 1 m is diluted, equal to 1 m, okay, equal to 1 m is diluted. And then whether it is strong or weak depends on the arrows, whether it completely ionized or incompletely ionized. Okay, it is the end of chapter 17.